Good afternoon, everybody. It's great to see you all. It's amazing what a few free drinks can do in terms of keeping attendance here going at the end of this conference. Normally, they give me this last slot, and it's like, you know, just the front few rows are here. Everybody else is taken off because the party was the night before. Welcome to the Case of the Unexplained. My name is Mark Russinovich. How many people have been to one of my sessions already at this Tech Ed? So, well, quite a few of you. How many of you were at the Manasseh-Russinovich duel this morning? Yeah. Who do you think won that? Me? Let's see, raise your hands, me. Yeah. Manasseh, where are you, by the way? I know he's in here somewhere. Because if I hear heckling, then I know that it's him back there. I'll just stop right here because most of you know a little bit about my background and what I'm doing at Microsoft, but I do get questions as I go talk to people. What is a technical fellow? Technical fellow is the highest technical position at Microsoft. There's an individual contributor track at Microsoft and a management track. Technical fellow is the equivalent of a vice president at Microsoft. In the individual contributor track, there's about 25 of us, and includes other people that you might have heard of, like Dave Cutler himself, Butler Lamson, Chuck Thacker, some of the people that worked on the original Xerox PARC Alto computer, which really created the vision for what a PC was going to be like. So I'm in some pretty amazing company as a TF. Now, people also want to know what does a TF do at Microsoft, and the answer is pretty much whatever we want to do. So it's kind of nice. It's kind of a nice deal that I got going. But actually, I'm a senior architect in the Windows division, and I work closely with the core team. There's several groups Windows is divided into, and the core team is security, file system storage, hypervisor, and kernel. And so I work most closely with that team, though I work across the other teams in Windows. Let's get started. Here's the outline for our presentation today. I'll just set the stage for what we're going to try to cover, what I'm going to try to achieve and share with you today in the introduction. Then I've got a number of different types of cases based on the symptoms, from sluggish performance to application hangs, error messages, application crashes, and blue screens. This is actually an instance of an ongoing series called The Case of the Unexplained. How many people have been to a previous delivery of Case of the Unexplained? So quite a few of you. And some of the things you're going to see are repeats. Obviously the concepts are going to be very similar from presentation to presentation. The nice thing about Case of the Unexplained is that I collect my own cases and I get people to send in cases to me. So every delivery I can do brand new cases. In fact, you can see there that I've got a pointer to my blog where I've got, and webcasts where I have some recordings of previous instances of Case of the Unexplained. So I've got blog posts that talk about some of these cases, including some of them that I'm going to present here. There's amount of material. I mean, it's kind of surprising, isn't it? The amount of material for troubleshooting Windows is huge. You wouldn't think that, but it's really the case. And so I actually have so many cases that when it comes time to do a new Case of the Unexplained, it's really hard for me to pick them. It's like children almost. It's like they're so cool. And I've got literally, I have to break them up into multiple PowerPoints because PowerPoint falls over at a certain number of slides. Imagine that. And there's actually 3 PowerPoints, a total of like 500 slides of Case of the Unexplained. So, and how many of you were at Sysinternals talk by Aaron Margosis and Tim Rickmeyer earlier today? Aaron mentioned he's working on a book, Sysinternals Administrative Reference, and we're going to have a whole bunch of Case of the Unexplained in that book as well written up. So the bottom line is that these are all based on real case studies, either my own or ones that people send in to me. And just because you've seen this, I recommend, if you like this material, to go back and look at the other ones, because each case really highlights different ways to use the tools and different techniques and different kind of intuition that people follow to get to a solution. Why do we need to even troubleshoot in the first place? Really, software is designed primarily for the expected scenarios. The developer programs the software with certain assumptions, and they test the software with those assumptions. Unfortunately, out in the real world, oftentimes those assumptions are violated. They're violated because applications corrupt each other's files, because an administrator will go and set security too tightly on a particular registry key or a file, or registry data gets corrupt for no apparent reason. All of these things end up taking the code down paths that the programmer never intended, never tested, where typically they would call an API, they don't test the result code, like call open file, they always expect the file to be there, and on that one day the file's not there, the code continues on as if the file was opened and starts calling APIs. Well, some of those APIs start failing. The application doesn't check those, and then ends up getting data that's corrupt because it didn't actually get data from the file, and then blows up. Or gets an error later on, and then reports that error to you instead of the root cause error that the file wasn't found in the first place, and the error is totally meaningless at that point, totally disconnected from the original cause. So what you end up with is errors manifesting themselves in all sorts of interesting and wonderful ways, from application crashes to hangs to misleading error dialog boxes. And the question is there something you can do about it? What I want to do here, oh, by the way, and what I would like you to avoid doing is violating this patent. Now, Microsoft PSS, we're free to do this because we cross-license with the patents with Dell. So if you get a PSS person saying reboot and does the problem go away, you know that we're not violating the patent in that case. But we'd like to do something a little more intelligent, because when you take the approach of let's restart the app, restart the operating system, and hope that it doesn't happen again, you haven't learned anything. You don't know what caused the problem. You don't know how severe the problem is, if it's going to come back to you and bite you again. So it's worth spending even just a few minutes to go try to figure out what's happened. Oftentimes, that will lead you to a solution. There's a new version of a driver up on a website. There's an application hotfix. In some cases, it's just a workaround. And when we're trying to get our jobs done and be productive, a workaround, in my book, is just as good or almost as good as an actual solution. You figured out what the problem is, and now you know at least how to avoid running into the problem. And that might mean uninstalling the thing for the time being until you get a fix, flipping a register key, disabling some functionality. So something where you can actually make sure that you don't run into the problem again instead of tripping on it like you would otherwise. So what I'm going to do is not give you the recipe. There's no step 1 if you've got a problem. Do this. Step 2, do this. Step 3. Unfortunately, troubleshooting is just as much of an art as a science. And the more you do it, the more you try to do it, the better you're going to get at it. And the more intuition you're going to build up about how to go about troubleshooting problems. It's a lot about just looking for patterns and getting familiar with the way the systems and applications behave. But there are some fundamental techniques that you need to have no matter what, and that's understanding the way file system access works, how to interpret registry accesses, the results from registry accesses, network activity, how to look at process trees to understand the relationship between processes, dig in a process to find out what's going on inside of it. And what I consider like the #1 troubleshooting tool is interpreting a call stack. So I'm going to teach you how to interpret a call stack. It's really pretty straightforward, but the call stack oftentimes gives you the root cause of a problem you run into. The tools that we're going to use, of course, some of the best tools in the world from this Sysinternals. So obviously, I'm not going to be able to show you all these tools in a 75-minute talk, but previous Case of the Unexplaineds cover the tools. So if you look at all the Case of the Unexplaineds I do, all of these tools are referenced in one or more of them. There's also some general Microsoft tools. Sysinternals tools, of course, are Microsoft tools. But there's also some ones that aren't branded Sysinternals that I've used in the Case of the Unexplained. KernRate is one. Visual Studio Spy++ is another. I've used those in previous Case of the Unexplaineds. One that I use in every single Case of the Unexplained is the Debugging Tools for Windows package, which you can get as part of the SDK or WDK, the Windows Driver Kit. Just search for Debugging Tools for Windows, and you'll get the download. Now, before I move on, just let me explain some things about the debugging tools. There used to be a separate debugging tools download you could go get. The policy around shipping out-of-band binary stuff has changed at Microsoft, so now it's included in a kit. Like I said, the SDK or WDK. The benefit of the SDK is that you can do a web install and go and just install from the web the debugging tools. If you go into the installer and say what you want, you can say just debugging tools. The WDK comes in an ISO, so you got to burn the ISO. The benefit, what I recommend you do as an IT shop, especially when you're going into troubleshoot machines that aren't connected to the internet, is go download the debugging tools. It's X-copyable. So you can take the debugging tools for Windows directory and X-copy it someplace, or put it up on a file server, and then run the tools off that, which is kind of nice. So you don't have to go do the SDK thing on every machine in your network. Let's start with sluggish performance now. How many people, by the way, have experienced sluggish performance on Windows? Well, I'm just kidding. I know everybody's going to raise their hand. So before I get into this case, which somebody sent in to me where they had some sluggish performance that they ended up resolving with some troubleshooting techniques, the tool that they used is Process Explorer. Now, how many people have used Process Explorer before? How many people have not used Process Explorer before? It's one person right over here, right there. Can you stand up, please, sir? No, I'm just kidding. So Process Explorer is a task manager replacement. Why don't I go ahead and pull it up and so we can take a look at it. There's got some obvious differences from task manager. The first thing you'll notice is that instead of just a flat list of processes, you see a process tree. Process tree is very simple. Parent-child relationship. Every process has a parent. There's one kind of primordial root process, and that is the system process, or the system idle process is a kind of a primordial root process. Everything is descended from that. What you see here are processes that are left justified. Those are ones that are orphans, poor processes. Their parents have died, and they're left on their own, so we have to left justify them because we have no parent to connect them to. So, for example, WinInit, its parent was a process called Session Manager, which exited. Well, there's another Session Manager here, but there's multiple Session Managers. They're clones of each other. One of the clones exited after it created this child WinInit. Services.exe, for example, is the Service Control Manager, and this right here, part of the process tree, highlights how the parent-child relationship can give you information. Because the Service Control Manager launches Win32 service processes, or Windows service processes, we call them. Every direct descendant of services is going to be hosting Windows services. So all these service hosts, and correspondingly, Process Explorer marks those with this pink kind of highlighting color, which I think is very nice. Then you scroll a little further down, you can see my logon session, starting with Explorer and all the things that I've run in this session, including ZoomIt and PowerPoint and Process Explorer and oops. So, stupid difference highlighting. The other things that you see that you don't see in Task Manager, well, you see some of this now in more recent versions of Task Manager, are to the description of the process. Yeah, there's, okay, I can't get away from it. So you can see descriptions of processes, you can see the company name. This is version information that the developers put right in the executable image that Process Explorer just simply surfaces up to you, which right but there can be helpful information about what the heck this thing is doing on your system. The blue colors are any processes running in the same account as Process Explorer. I'm running as me. Any blue processes were created when I logged in, and then the system creates some processes running as me, you saw, like DWM, the Desktop Window Manager, to run in my account context, so that will show up in blue as well. Some of the other things you can do, well, you can dig in and get some more detail about a process by clicking on its process properties. So here you can see it's Windows Explorer. I've got image signature verification turned on. This will actually verify the digital signature or try to, on the image if it's got one, and tell you, yes, the digital signature does match up. This is the legitimate Microsoft signed Windows Explorer binary. It's version 6.1. Here's when it was built. Here's its current working directory, command line, path. You can see it's an orphan. Explorer's parent, by the way. Anybody know Explorer's parent? For a little bit of trivia here. What's the process that launches the shell? Anybody know? It's not WinLogon. Userinit. There we go. This started at this time. It's a 64-bit process. You can put in comments here. So I put in a comment. The comment is visible here in the tooltip if you put in a comment. And you can also add a comment column. One of the things that column is good for, especially on your mission-critical servers, running Process Explorer, identifying the purpose of every single process on there, and adding a comment for it. And then you can go back and look later, see a process that's there without the comment, you know you haven't looked at it. What the heck is that thing doing there on your mission-critical server? Go try to figure it out. Then other tabs, Performance tab shows you detailed performance, updated in real time according to the Process Explorer refresh rate, the prior CPU information, including how long this thing has run, virtual memory. For those people that were at the Pushing Limits talk, you understand this stuff now. Those people that weren't there, you probably don't understand it. Physical memory, just kidding, you probably do. Hopefully you do. I/O, here's the I/O counters. that you'd see in perfmon. Here's the handle counts, both Windows Manager and operating system. Then there's the performance graph, which is like Task Manager's system-wide performance graph, except focused just on this process. This is useful if you've got a process that, for example, has erratic memory behavior. This graph will show you the memory behavior, and then a tooltip, you can move over the timeline to see what time maybe you had a spike in CPU usage, or when you had a spike in private memory usage, or a spike in I/O. The Threads tab will come to later, the TCP/IP tab. For some reason, Explorer's got an endpoint open here at port 64460. I don't know why it's got that open. Anybody know why Explorer's got a UDP port open on my machine? Malware? That's what I thought. Actually, I don't know. Security tab, this shows us into the token of the process. I mentioned that processes are running as me that are in blue. You can see that right here, mtdev markrus, and you can see this, my security identifier right here, which corresponds to that. The groups that I belong to, and I belong to lots of groups that aren't resolving because domain name resolution for the groups isn't working because I'm not connected to the domain. But here, the group SIDs for the SID that you've got, or the group that you've got selected shows up down here. So console logon is S-1-2-1. And then finally, the privileges. Explorer is running a standard user, so you're not going to see administrative privileges you would see in an elevated process like Process Explorer itself. Environment variables, sometimes useful for trying to figure out where the process looking for DLLs. Why is it looking in this particular directory? Might be because of the path environment that this thing launched with. Every process starts with a copy of its parent process environment block, but then it can set its own environment variables and change them that will affect its own behavior. And then finally, the strings tab. This is useful for hunting malware. A lot of malware programs pack themselves on disk. They encrypt themselves or compress themselves so that when you go look at them, they just look like garbage. But when you run them, they inflate into memory as a fully operational program. One of the things that this lets you do is look inside the memory of that of the image in memory to find strings that might give you a clue about what this thing is for, maybe if it's malicious, what kind of malicious thing it is. So there's some other final things that I'd like to talk about. Well, the system information graph, let's take a look at that. The system information graph shows you a view of CPU usage, including the timestamps that I mentioned, commit history, I/O history, physical memory history, and then down here, lots of detailed information about those different types of information. And then there's a few options, and there's some options that I always enable on my system. Hide when minimized, and then I go mess with the Win7 tray thing to make it show up always instead of hidden in that tray cluster. I could, of course, work around that, by hacking the system to make it always show Process Explorer, but now that I'm part of Microsoft, they'd probably frown on that, so I don't do that. So you got to do it yourself. Allow only one instance, confirm kill, which will, you check that and it won't prompt you if you wanted to say kill a process or close a handle. And then you can literally replace Task Manager. And that's what I always do, replace Task Manager. So I've replaced Task Manager. And now, what's people's favorite way of running Task Manager? Because there's like lots of different ways. Control, Shift, Escape. Voila. Task Manager. And I'll show you later how that works using another tool. Finally, one last thing, because there's just tons of stuff that I don't have time to cover here. You can configure column sets and add lots of additional columns. Here's all the different types of columns that you can add to the main display. A lot of this information is available on the Process Properties dialog, but if you are constantly referring to this kind of stuff, you might want it just right on the main Process Explorer display. Like, what window title does the process have as its main window? Verified signer, version, all of this stuff. Performance information if you're interested in analyzing the performance of the process. This is I/O and CPU, and then there's a separate one for memory because there's a lot of extra memory things. And then there's some other views that we'll talk about that I don't have time to talk about, actually. The handle view and DLL view, looking at the open handles the process has, as well as the DLLs it's got loaded. And then there's .NET information, which we don't really care about. And then you can configure the status bar. So that's just a whirlwind tour of Process Explorer. Now let's get back to the case at hand here. In this case, Sluggish performance shows up in a number of different ways. One is I always have Process Explorer running in the tray so that I can see the CPU usage in the tray icon. If I see the CPU usage green, solid green for a period of time, I know that something's burning my CPU. Why is that bad? Even if it's not causing sluggish performance, if I'm on a laptop, it's burning my battery. My power is going to run down a lot faster than it would otherwise. One of the unfortunate things, in my opinion, of the multi-core revolution, where now everybody's got at least 2 cores, even people that are walking around, we don't have them on netbooks yet, but I'm sure we will in the near future, is that if you've got a runaway process, you don't necessarily feel it. It's there burning your CPU, you're cruising along, and the other core, you know, the system's not as fast as it otherwise would be, but it's really typically hard to tell that that's going on. In this particular case, the guy had 1 CPU, and it's very easy to tell when somebody's pegging the CPU and you've got a 1 CPU system. Everything starts to get slow. So he noticed the sluggish behavior. He pulls up Process Explorer and he sees that the process in question is WMI-PRVSE.exe. And you can see that it's been burning CPU for a while. That's the mini graph there that's at the top of the Process Explorer window showing it's been green for quite a while. Anybody know what this process is? It's the WMI provider host process. Now the problem here, he's kind of stumped. That's a host process. A hosting process is one that can host other components. And there's a number of different types of host processes. You can see there at the bottom. Service host hosts Windows services. Internet Explorer hosts third-party plugins. MMC hosts a snap-in DLL or more. At DLL host loads a COM server DLL. Run DLL 32 loads a control panel DLL. All of these things, when you see these processes and you suspect that they're a problem, they're not typically not the problem. It's usually something they've loaded because they're just containers for the most part loading this other stuff. So his job wasn't done at this point. WMI provider service, what inside of it is causing the problem? It's probably not that executable. It's something inside of it. So you need to turn to threads. So let's just briefly talk about a process and threads. A process is a container. It has an address space associated with it, a security context that we've talked about and saw in the Process Explorer properties. It's got a handle table associated with it, which the operating system uses to keep track of open operating system resources. It's got a number of different performance characteristics or attributes that are kept that you can look at in things like perfmon and Process Explorer. Processes don't actually run. It's a thread in the process that run. And each process, every process on the system has at least 1 thread. Typically, they have more than 1 thread. And it's the threads that actually are given CPU time that execute the code in the process. Every thread shares the entire process container. They're all buddies in the same family. They can mess with each other. They all have equal access to the handles and the address space. One bad thread in the process, and all the other threads are affected. That's the nice thing about a process. It is a reliability boundary. So one bad process doesn't affect other processes typically. So how do you take a look inside of a process? You need to look at the threads. Now you notice that I've got some something burning my CPU. And if I zoom in here on the tray icon, it's service host. This is the tooltip showing me the process at the time I hover that was consuming the most CPU. And it's a service host process, which is a Windows service hosting process. Let's go find which one it is. And it's this service host. You can see it's consuming about 55% CPU. The thing about Process Explorer and most container-type processes is it will show in the tooltip the components that are loaded into that process. For example, for service host, it will show me the services that are running inside of that service host. For Internet Explorer, it will show me the tabs running inside for Internet Explorer 8 because it's got a multi-process model. And do I have any other hosting processes running at this point in time? It doesn't look like I do. So if we had a run DLL or a DLL host, it would also show us information about those. Service host being a container, my job isn't done here. Let's go take a look at the threads now inside of this service host. Now one of the things, let me close this up for a second. One of the things that Process Explorer can do for threads, each one of these lines represents a thread in the process, is display start addresses for those threads. The way that most useful way to use Process Explorer is to configure Process Explorer to reference symbols from the Microsoft symbol server so it can pull down function names for the Microsoft binaries that are in the box. And that's why you see for the highlighted line, service host wmain crt startup, is because I've gone over here to the options, configure symbols, and I've pointed it at the public symbol server. No need to write this down. This is documented right in the debugging tools for Windows help page, or in help file it says this is the URL. It's been this way since like 1998 for the public symbol server, so I've gotten really good at typing it really fast. If you don't have symbols for the image, then what you'll do is just see a raw offset, and it looks like I've got symbols for everything in here, except for this process, this thread right here, where you can see it's got this weird offset here. It's because I don't have symbols for it. So which threads are consuming the most CPU? Well, this one, service hog. It's pretty obvious that we know what this is. This is a DLL here. If we double click on it, if we click on the Modules tab, then it will show us information about this particular DLL, that it's a service host CPU hogging demo program, which isn't surprising given its name. It's pretty straightforward. I wrote it back in 2004. I'm pretty proud of this little program. So that is ideally the case that you run into, is that the thread start address tells you right away what's going on with that particular thread that's consuming CPU. It's a third-party component. Let's go ahead and freeze that one, and I'm going to suspend it, which you can do with threads. Now, this you should only do in a pinch when you know exactly what you're doing. I'm a professional driver here on a closed course, so I'm free to suspend this. Like, your mileage may vary if you're going around suspending random things on your system. But we've got one other process here, one other thread here going crazy. We'll come back to that in a second. Let's go see what happened with the case that we're looking at when the user, or the administrator, went and looked at his WMIP provider service process. The thread that was using CPU had its start address in kernel 32 and the create thread function. This is a generic start address. This is really the start address for every single thread. What this says is that this started in a generic thread function that's called into something else. So at this point, he doesn't, no more clues yet. Still looks like system stuff, but he suspects that it's a third-party plugin. He needs to dig even deeper into this process to see what that thread is doing right now. And the way that you can do that is by looking at the thread stack. How many people have analyzed a thread stack? So a few of you have. Now, it's really pretty straightforward. You know that programmers divide their code up into functions. And functions are even implemented in separate images, different DLLs. When one function calls another function, typically it wants to pass it some arguments, some parameters. And then when that second function finishes, that function needs to know how to get back to where it was called from in the first function. The place that it stores that information is in the threads stack. And so what it'll do is put the arguments on the stack, call the function, and the call operation itself sticks the return address to function 1 in the stack. Function 2 then goes and looks at the arguments, does its thing. When it's ready to return, it finds the return address on the stack and continues execution there. So you can look at the stack at any point in time and see kind of the history of the way functions called each other. Here, function 1 calls function 2, calls function 3. You would see that in the stack. Let's take a look at the call stack now for this thread that we've got consuming CPU. And you can see that it started in NTDLL, TPP worker thread. This is just a generic thread pool worker thread, part system thread. But it's obviously consuming CPU. Some other component is feeding this worker thread work to do. What is that work? Who is it? Let's take a look at the thread stack. And what you'll do with the thread stack, you read this from the bottom to the top in terms of time. The thread started its life in NTDLL user thread start, which called base thread init thunk, which called TPP worker thread, which you can get the idea, called into service hog, and service hog is called into get tick count stub. The key here is to look for suspicious DLLs. What DLL looks suspicious in this thread stack? Service hog, right? This is it's a third-party DLL, obviously, and third-party DLL is typically what you're looking for here, some clue about what's causing the problem. So that would be what we would zoom in on. And if we go over to the services, we can see that, well, sure enough, there's a service hog service sitting inside of this process, which describes itself as needlessly hogging the CPU. So something you probably don't want to run on your server. What did this person run into? He looked at the thread stack and saw that it was this DLL assetadvisor.dll. Anybody know what DLL that is? Associated with? Well, he did a search, and I'm going to go do the search. Isn't that screen beautiful? Isn't that picture beautiful? Did you hear about Google? They like our background so much that they copied it for a while, for a few hours until everybody made fun of them for copying us, and then they took it down. So I'm going to show you lots of pretty pictures for Bing's background here. So this is a search. This is what a search he entered: CPU usage assetadvisor.dll. And Bing is just so awesome. Look at that, the first one. After you install, it is getting better, you got to admit. After you install SMS 2003 SP3, the WMI provider service process may generate high CPU usage on client computers during hardware inventory related operations. Well, and guess what? There's a hotfix down here. Download the package now. So, bam, basically 3 steps. He identified asset inventory, did a Bing search or some other search, and then bam, was taken right to the answer. Here's another case that somebody else ran into and sent in to me. The user noticed that the system was sluggish, ran Process Explorer, and saw that the system process consuming CPU. You can see there in the system information dialog that we've got a 2-core system. One of the cores is completely pegged. So a thread is really consuming 100% of the CPU on one of the cores, which ends up a total of 50, half this total capacity of the CPU on this system. And you can see the system process there showing 50% CPU utilization. It's another example of a hosting process. The system process hosts Windows kernel threads for both the operating system and device drivers. So he needed to go dig into the system process. Let's quickly dig into my system process. Actually, let's go take a look, deal with the service hog thread first. Threads, and suspend this guy. And then let's go take a look at the system processes threads. And you can see that there's lots of threads in here. A bunch of them are in NTOS kernel, which is the operating system kernel. But then you'll run into ones that are in device drivers, like NDIS device driver, the ACPI device driver creates threads. The system process is running away with the CPU. What thread is responsible? And when he went and looked at which thread was responsible, you can see right there, alcxwdm.sys was pegging the CPU. He went and looked at what thread that was, double-clicked on it to look at the version, and saw that it was Realtek AC97 audio driver 5.10.06203. He goes to their website. Lo and behold, they've got a new version. It's kind of hard to tell from the way they changed the version number. I think they did this to kind of fool people. Nope, no problem here. It's just fine. Everything's fine. But that new version, he installed it, and the problem didn't show up again. So again, a few clicks of Process Explorer, and the problem solved. Let's turn our attention now to application hangs. This is a different kind of problem. This is where application starts, or you do something, and bam, it just goes off into the weeds. Who knows what it's doing? Outlook I can't help with, but we'll talk about other problems that you can deal with. And the tool that we're going to use for this is Process Monitor. How many people have run Process Monitor? Wow. How many people have not run Process Monitor? Wow, you're still willing to raise your hand. How many people run FileMonitor before? And Aaron asked this earlier, and I was disappointed by the answer. How many people still run FileMonitor? All right, you guys are definitely excused. So the Process Monitor is just so much more powerful than FileMonitor. has more, and here's the selling points for you guys still running FileMon and Regmon. More advanced filtering, operation call stacks, the number one troubleshooting tool, as I mentioned. Boot time logging, data mining views, process tree to see short-lived process. Dave Solomon came up with an expression, a motto kind of for Process Monitor. When in doubt, run Process Monitor. This means whatever the problem is, you're like, there's no way Process Monitor can solve it. You run Process Monitor. When my daughter comes home from school with homework questions, I have her run Process Monitor. It will oftentimes surprise you by showing you the answer. Let's take a quick tour of Process Monitor. So I fired it up. It's the default view here. We've got the sequence number, which is the entry in the display, the time of day of the operation, the process name. The tooltip will show you the version information and description and path to that executable image, the process ID, the operation, registry operations. Here you see file operations, the path to the operation, whether it's a registry key or a file path, the result, and detailed information over here on the right side. This is another aspect of Process Monitor. It collects tons of information. So if you do a registry query, or you do a directory listing even, or you open a file, you can see exactly, here's an open file, it'll tell you exactly what parameters were passed into that open file operation. There's information you can dig into on a particular event. By double-clicking, you can see all the information available for an event. You can see more detailed information about the process image and the path and the command line it launched with. Again, user, authentication ID, when it started, what its integrity level is, tons of information, the DLLs that were loaded at the time of this particular event. We're going to come back to the stack in a minute. You can add all that stuff as columns, too. Application details, event details, and process-related details. You can see the process IDs checked. Process Monitor also has very advanced filtering capabilities. At first, it has these filters, which are class filters, or category filters, we call them. Let's say that you don't want to see the registry activity, just the file system activity. Just clear that, and you've just filtered out the registry. These are non-destructive filters. Again, a difference from FileMon or Regmon. I can bring that stuff back. It's just not displayed. It's still, Process Monitor is still holding on to it, and then bring that stuff back. Then, in addition to that, I can drill down pretty precisely and quickly into things. One of the filters I can set as a quick filter. Like I want to see just Explorer, or I want to see just read files. I just right-click on what I want to see and do the quick filter thing. Here are all the read files now. Control-R to reset the filter back to its default. Or I can do very complex filters. So I can say, you know what, process, or path, this is the most common one that I set. Path begins with, you know, C:, demo, or whatever. And you set that, and then you're going to set a filter that includes just that. While I'm here, I'm not going to bother doing that because you can guess what the result will be. But what I'll do here is show you that there's some default exclude filters. This is what you can turn on when you go to the options and set advanced monitoring. This filters out stuff that you're typically not interested in seeing when you're troubleshooting problems. You don't want to see stuff from the system process, which are the drivers. You don't want to see stuff that's the raw I/O operation names or MJ whatever, unless you're a file system driver developer. You don't want to see the NTFS metadata stuff because you can't really do much about that. So those things are filtered, and the page file as well. So those things are filtered out by default. If you were in Aaron's talk, you saw that one of the features we added to Process Monitor just in the last few weeks, which several people requested, was, hey, you know what, I'm playing around with filters when I'm troubleshooting. I set up filters, I look at what's there, oops, I set it too regressively, I need to go back and change it. And what would happen is when they deleted filters, they'd have to go back and recreate them. So what we did is add these checkboxes where you can disable a filter. It's still there, Process Monitor remembers it, but then you can set this and apply that effective filter, but let's say, you know what, oh, I want that back, so I want to set that filter back there, and this as well. You can just recheck it without losing the filters. You can save the filters, you can organize the filters, just lots of filtering capabilities. There's just tons of stuff to talk about with Process Monitor. I don't have time to talk about it all again. I just want to show you one more thing about Process Monitor, and that is one of the most powerful tools, you can see here in the tools menu a bunch of data mining type stuff. The one that I find the most powerful and I use all the time is the process tree. The process tree, as you'd guess, is just like Process Explorer's process tree, which shows you the tree of all the processes that were running at any point during the process monitor was running. Even if they didn't do anything, these are all the processes. If they were sitting there totally silent, you're still going to see them in this process tree. You're going to see grayed out the processes that have exited. Like there was a search filter host that ran for a while. Here you can see its timeline which related to the other ones, then exited. Over here you can see exactly when it started and exited. And the reason that I find this useful is like, okay, I'm interested in just activity by PowerPoint, and I don't want to have to go digging through the entire trace looking for PowerPoint. I can select it, and this is new too. I can just say include process. And I've just set a filter for PowerPoint. So with that, let's turn our attention back to that case, which I haven't even introduced yet, for what happened. And this was my own case. This was, how many people were at TechEd US last year? You see the keynote? So I was up there doing the keynote thing. Well, this particular case I ran into myself with the Jason Lesnick, who was managing the keynotes for TechEd. When you're doing a keynote, you get some guy that sits and helps you with the keynote demos. Does like all the grunt work for you, which is kind of nice. And we were going to do this demo where I ran an app that was a buggy app that Aaron Margosis wrote. Aaron, are you here, by the way? Yep, there he is, Aaron. Actually, did you write this or Chris? Stock viewer. Oh, Chris Jackson wrote this. So Chris Jackson wrote this buggy program. He did his buggy on purpose to highlight application compatibility problems. So one of the things I was going to show was how the app compat shims that you create for Vista work on Win 7 as well. I was also going to show App Locker, where you can set rules on what programs launch and don't launch. So I needed to digitally sign this so I could show how you can create this rule that says only let software from this publisher run on the computer. So I signed it with the Sysinternals signing certificate, and I gave it back to Jason. Jason calls me up a few minutes later and says, uh-oh, we've got or about a half an hour later, he calls me up and says, uh-oh, we've got a problem. I was running through the keynote demos, and that stock viewer program, which used to start right instantly, now it takes like 2 minutes to start up. So I was like, okay, go get a process monitor trace for me and send it to me. A few minutes later, I got the process monitor trace. Let's go take a look at what I saw. And you know what, when he told that to me, I'm like, well, so what if it takes 2 minutes for the stock viewer thing to start up? I mean, Microsoft keynotes are pretty boring anyway. Nobody's really going to I can tell jokes during that time or something. So this is what I saw. Let's find stock viewer instead of filter for stock viewer. Oops. And now I've just got stock viewer. Now instead of, I'm going to cut right to the chase. What I did was try to find gaps in the timestamps that might have been long gaps to see, okay, what happened right before the delay? Where's the delay here? And what I did is eventually notice that there was a pattern. And I'm going to, whoops. And I eventually narrowed the pattern down to this. And if you look, it's reg open keys of HKey local machines, software, Windows, current version, internet settings, connections. And here's 227.21, 227.32, 227.44, 56. A gap of exactly 12 seconds in between each of these, and it's a whole bunch of them that add up to that long delay. So what's going on around this? So I cleared the filter and then started poking up around it. Crypto stuff. So crypto crap providers. Well, what do you think could be happening when you digitally sign an app and then there's crypto stuff going to the network? Yeah, CRL, certificate revocation list check. So that's what clued me in there. And then I'm like, all right, is this a .NET app maybe? So I double-clicked on it, went to the Process tab, and looked to see if this thing was .NET. Because I'd heard something about signature verification, and .NET. And sure enough, it's a .NET app. So I go do a web search for slow startup .NET app. Let's go take a look at another cool Bing picture. Well, actually, I've already done the search on this one. This one is Fix, .NET Framework 2.0 managed application that has authentic code. Signature takes longer than usual to start. Well, how long does it usually take? And when they say something like that, you know, it took 5 minutes instead of 4 minutes or something, you know. Anyway, so you come down here and it says, okay, you can download this hotfix, which, by the way, is included in Vista and Win 7 for the .NET Framework, where you can add a manifest file that has this text in it and just stick it in the same directory as the app, and it will skip that check. So I send him back, and by the way, this just puzzled the crap out of me because, okay, the machine's not connected to the network. And the thing is checking the digital signature to see if it's been revoked. But you know what? If we can't talk to the certificate revocation server, we'll just pretend like it wasn't revoked. It's just fine. That's real secure. So, anyway. I emailed the .NET team about it. They're like, oh, yeah, we don't know why it does that. The guy that did that, he doesn't work on the .NET team anymore, and we're afraid to change it now. So it's kind of really interesting being on the inside and hearing the stories like that. There's always a really good reason. So think about that next time you run into a problem with Microsoft software. There's always a really good reason. It just might not be obvious. Anyway, I sent back this file to him, dropped it in the directory, and whammo, stock viewer ran, and you saw that in the keynote demo that it started up just fine. Problem solved in a few minutes with Process Monitor. Let's take a look at error messages now. This one was really pretty cool. This was sent to me by Microsoft product support, and I get a lot of cases sent to me by product support these days, which is kind of cool because those guys are pretty good troubleshooters, and it's really gratifying or fulfilling to see those guys actually, their jobs get easier helping Microsoft customers solving problems with the Sysinternals tools. So this one starts out when a customer contacts PSS because they're running SQL reporting services, SRS, and they're trying to attach an image to a particular report, and it just won't attach. The support guy, he starts investigating. Of course, you want to try to have the customer try it in another identically configured system. They've got another SRS server. They try it there. It works there. The PSS guy spends time setting up the exact same environment with the exact same version of everything in-house, tries it there, still works, tries it on a bunch of different OSs. Finally, after 34 hours of working on this thing, he finally says, okay, you know what, I need to take a break and go to the restroom. That's how dedicated those guys are. So he's in the restroom, and he's like, oh, what was that? Process Monitor. I should run Process Monitor. So he jumps out of the restroom, comes back to his cube, and fires it up, and, well, actually asks the customer to go get a trace from that working system and from the failing system. And this highlights a particular troubleshooting technique, comparing a failing systems log with a working systems log. Let's go and pull up that log, or those two logs. So SQL fail, and launch another instance of Process Monitor, and open SQL work. And I wish the arrow snap worked on the top and the bottom, but it only works on the side and the side. You want that too? You know what? They don't listen to it if it comes internally. They're like, you're not a customer, so we can delete that email. What? Click on the... Oh, wow. Well, that almost worked. All right, you know what? I've just... Thanks for that tip. That was, Okay, so here we go. So what he does is he starts scanning the files side by side, or marching through them. And I'm going to get right to the place where things start to get interesting. So he sees right here, if you look up at the top, let me scroll this over a little bit. So we're seeing a reg query value of this hkeysar thing, some GUID, prog ID, and it comes back with a string value cdo.message1. And he comes across and he's like looking at the other trace and he says, oh, okay, here we're lined up right here. We see that reg query, cdo.message1. What's the next one? Next operation is a close key. Let's look at a few operations and then compare side by side. Close key of that, close key of the parent key, a reg open key of HKCU, a reg open key of HKCU control panel desktop, and then an open key of the desktop. What do we have in the other trace? We have, here's the close of that prog ID, here's the close of the parent, here's a reg query value of code page 28.591, here's a query open of an LLS file. Anybody see what's going on here? A little bit of a difference. Here's the control panel desktop stuff that we saw in the other trace. But these two lines, where'd they come from and what are they doing? And why don't we see those in the other trace? So he goes, at this point, and does a reg jump to on the system where it's working. And Process Monitor has this capability when you say jump to of putting reg edit under a trance and making it do whatever it wants to. And so you can jump right to the place in the registry or the file system where that line references. And so that's what he did. And look what he saw on the system that was failing or working. Let's take a look at that one. Here's the code page key. Here's all these NLS entries. Here's the failing system. Missing entries here. So he exported this side, imported it into that machine, problem fixed. Anybody tell me what happened to those values? Because if you do, PSS has got a job for you. Nobody knows. It's one of those things. Nobody, who knows where that happened? Okay, here's another case that I think is interesting. Somebody else ran into this. And this is going to introduce another tool here in a second. User complained they were unable to browse the web on this network, so they called the network administrator. They just got a connection error from IE. One of the things that you do is go, okay, what's different about this guy's machine or this girl's machine? This machine had just been migrated between domains. And so oftentimes those differences that can lead you to a clue, sometimes they're just red herrings. They lead you off away from the actual problem. But that's the one difference that he could think of. So he goes about troubleshooting. Deleted the IE cache, problem still there. Checked DNS servers, still working. A gateway still working. Tried other outbound ports. You can see an FTP connection here going out from the machine works. It appears to be HTTP only. So he captures a log of the system when it's doing this thing. Let's go take a look at that log now. And in this case, he scanned through the log and didn't see any interesting third-party activity. So he starts looking at the thread stacks for each event. And you can look at a thread stack in Process Monitor by clicking on the event and going to the stack. And he looked through the stacks one by one, which I guess I could show you here. You can just go one by one, clicking through here. And he eventually got to this line right here. And he looks at the stack, and he says, this has got a third-party DLL in here, or a driver in the stack that I don't recognize, vsdant.sys. What is that? It's the True Vector device driver from Zone Labs. And he goes, well, that's weird. I never have or have Zone alarms installed on this machine. So he goes and does a search. Here. Wow, and look at that background. Isn't that cool? It's beautiful. So he does a search here, True Vector vsdant.sys, to see what the heck this thing is. And he comes across, oh, what is it? Well, there's the answer right there. It is a file that's part of the vector alarm stuff, but then later on down, he finds this. All right, it looks like this thing might also be related, and I've got to use the zoom it drawing thing at least once, to Cisco's VPN client. Here, wait, let me, there, VPN client, crash, and causes a crash. The VPN client, and says, oh, you know what, we did have the VPN client installed on this machine, and in fact, we had uninstalled the VPN, and he went and looked at another machine where they had the client and saw that the stateful firewall was configured on the other machine in the network that had the VPN client installed. Turns out that that stateful firewall is the zone alarms thing. And he just uninstalled the Cisco client before switching this guys between domains. Looks like it left something behind, this VSDANT driver that was causing IE to screw up. So how does he deal with getting that VSDANT driver fixed? The uninstall didn't do it, so how does he disable it? He turned to auto runs. How many people have run auto runs? How many people have still run msconfig when you're trying to troubleshoot stuff? Come on, raise your hands. msconfig fans, raise your hands. All right, you know what? Using msconfig is like putting a blindfold on, tying your hands behind your back, and a string of rope around your legs and trying to walk through a dark room to the other side. That's my analogy for msconfig. It really shows you almost absolutely nothing. And I'm not even going to like give it any kind of respect by even running it to show it to you. I'm just going to run auto runs. Go right to auto runs here. No, you can't. Actually, that's a great idea, actually. So what I've done here is I've run auto runs with all the filters turned off. By default, auto runs will run with the filter turned on to hide anything that's not signed with the Windows signing certificate. In other words, to try to just show you all the stuff that was added onto the system. What I've done is turn that off so you can see everything that it shows you, because it shows you even built-in OS stuff as well. Now let's abort this scan and turn on the hide Microsoft and Windows entries, which is actually the most useful for trying to troubleshoot a third-party application problem, because Microsoft stuff is never responsible for the problem. Actually, it's not always true, but it's generally true. So if you're interested in seeing what msconfig is most closely corresponds to, it's the Logon tab. The Everything tab shows you all the contents of all of these tabs put together. The Logon tab shows you the stuff in the run key and the startup key and the run key, the other run key. Then the Explorer, shell extensions, Internet Explorer, browser helper objects and ActiveX control, scheduled tasks, services, drivers, codecs, boot execute, image hijacks. Remember, Process Explorer replaces Task Manager? There it is. Image file execution options. It configures itself there, so whenever somebody runs Task Manager, they get redirected to Process Explorer instead. App init, known DLLs, sidebar gadgets, blah, 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 blah. Lots of stuff. So one of the things you can do with this is when you click on something, you get information, detailed information, size, timestamp, version, the raw registry path or file system path where that thing is registered. You can right-click and say Search Online. You can, if the process, it's actually a process and it's running, you can launch and say Process Explorer. You can look at the file properties, all from auto runs. You can see the checkboxes just like msconfig. You can disable something. So what he did was figured that driver is configured to start up somehow. He goes into auto runs. He finds VSDANT. And by the way, I can show you that actual log file because you can save and open these things. So you could collect a auto runs log file from somebody and then send it to somebody else to look at. And here's the VSDANT true vector device driver. So he unchecked it. You can't do that on a loaded save scan, but he unchecked it and then rebooted the system, and IE was working again. This highlights another important technique related to troubleshooting. Do no harm. Always try to do stuff that can be undone. How many people have been burned by not following that before? Yeah. It's like, oh, I know that's it. Let me just go ahead and delete that file, and system won't boot again anymore. Oh, that's not good. So always make sure that you can undo what you've done. In that case, is instead of deleting stuff, unless there's stuff that you really know you want to delete, like, I mean, while we're here, I might as well just go ahead and clean up my system because it gets polluted every week or so. Auto runs, where are you? Oh, there. Wait. Oh, there it is. Yeah, it gets polluted every week or so. It's still running, but I've already got some stuff where I need to get rid of. Actually, I like the mini player, so no, I don't use that. I don't know what it is. This is going to take a while, so I'll come back and clean it later. But there was definitely some stuff. Oh, here, no, that's not it. Oh, here we go. So basically everything in this run key, bad, 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 bad. So I'll deal with that later. But just FYI, keep your own systems clean, get rid of that kind of bad stuff. Let's talk about application crashes now. How many people have experienced an application crash in the last year? No, just kidding. Last day. Last hour. Anybody in the last hour? Well, okay. That was really cheap. Now, the thing is, in most cases, like Outlook, potentially, there's nothing you can do about it. It just is buggy software that crashes. Not saying it's Outlook. No, it's that. Anyway. Anybody from the Office team in here? Yeah. I'm in Windows. We're allowed to do this. They do it to us, too. So they blame it all on us. It's Windows' fault. So most cases, you can't do anything about it. But really, what you always want to do is take a look at the crash because it might be a third-party plugin that's infected the process and is causing it to crash, or it's loaded inside the process. If it's the process itself, it's the application itself, you're out of luck unless it's LOB app and you know the developers inside, and then you can go harass them. If it's third-party commercial software, maybe you can contact them and see if there's a fix or an update for that application. But no need to troubleshoot anymore. The process crashed. Go find a new version or get rid of it. The question is, did something else cause it to crash? And that's where you need to do some crash dump analysis. The first step in crash dump analysis is finding the crash dump file. Whenever a process crashes in Windows, a crash dump file is generated. In other words, a dump is taken of the, and I just have to say that, it's always fun to say that, of the process address space. On pre-Vista systems, finding the dump was very easy. You just go into that we're sorry that we had a crash, we're sorry that you're inconvenienced. You click on the click here for information, you click on the click here for more technical information, and it'll show you the path to the dump file. So before dismissing that dialog, go find the dump file, and then you know where it is to find it. Now, on Windows Vista and higher, some things changed. First of all, we got so tired of apologizing, we don't do it anymore on that dialog. We just tell you the obvious, like your program has stopped working, like you couldn't tell. And then what we do is save the crash. But where does the crash go? We don't actually save a crash. We actually delete the crash after you dismiss that dialog. So don't dismiss that dialog, and then you can go find. Then what you can do is attach to the process. So attach to the process, and you're looking at that process. It's kept in this zombie dead state, in a coma really. It's really dead, but it's still there. And then you can go and do some looking around its insides to see what might have caused the problem. The other thing you can do, another thing you can do is enable dump archiving on Vista and higher. And this is what I recommend you do with all your systems in your network, your client systems and your, if you're Win 7 or Vista, is to go set this registry key, HKey local machine software, Microsoft Windows, Windows error reporting, local dumps. All you have to do is create that key, and then what Windows is going to do is save dump files in the user profile directory of their crash dumps. And that way, if you're getting crashes on your system, you can go back and see if there's other ones, older ones, that can give you more information. Now that you know where the dump is, let's analyze the dump. That's the next step. And what you do is use WinDebug, the debugging tools for Windows debugger. And your goal here is to find the thread that has caused the problem. And the way that you're going to identify that is by looking at the thread stacks. Well, actually, let me show you. First thing you're going to do is to do a bang analyze -v. Actually, I'll show you that on a live dump from somebody. But what you want to first do is see if the debugger will tell you what the problem is and show you about the thread that caused the problem, the thread that actually tripped and caused the exception that made the process crash. You want to look at its stack because it's most likely to have the third-party DLL if it's responsible for the crash there in its stack. What you want to do at that, of course, at that point, if you find third-party DLLs in the stack, is go disable the extensions, go check for new versions of the extensions, or uninstall them altogether if it's really causing you a problem. So let's get right down to a case here. In this particular case, a user tried to open a Windows Media video file with Windows Media Player, consistently 100% reproducible. They open the file, any WMV, and they get this crash. Media Foundation Protected Pipeline exe has stopped working. So they open up the dump file. Let's go take a look at that dump file. So here we are, and the first thing he did was type bang, analyze -v. That's my new signature, by the way. Bang, like, you know, Iron Chef or whatever it is. So instead of bam, it's bang. It's not Bing. You can't type Bing analyze -v. That doesn't work. But bang analyze -v. All right, that's not funny. I shouldn't do the bang thing. All right. Had to try it. It's Friday afternoon. Got to try it. Oh, yeah. Really flummoxed at this point. No laughter at that joke, and it's got me all thrown off. This is going to take a second because it's trying to resolve symbols for images that don't have symbols up on the public symbol server, and we've got this slow network connect. Everybody, please turn off your wireless again. So let's come back to here we go. You can see there's lots of third-party stuff loaded in here. All right, this will just take another 5 or so minutes, and then we'll be good. Wow, all right. It's taking longer than, of course, it does when you do it ahead of time. So why don't we just flip right to the slide, kind of like Julia Childs, as Aaron calls her. This is what you're going to see. Bang Analyze is going to spit out that it thinks the module responsible is, using its heuristics. It's going to find the faulting thread, do its magic, say, I think that EVR caused the problem, EVR.dll. Turns out EVR is a Microsoft DLL. He went and looks at the properties. It's not a third-party plugin. So at this point, it's like, all right, is there a problem with EVR.dll? This is one of those rare cases where, in fact, it was a Microsoft issue. So he does a Bing search for EVR monitor crash. Let's see what we find here. Well, there's a support article right here. Let's see if this applies. The video application crashes when you play a video if 5 or more monitors are attached to the computer. If you've got that many monitors attached to the computer, you know, it's like, I can't believe you thought that would work. Well, it turns out that he did have 5 computers attached to his 5 monitors attached to his computer. What industry was he working in? Financial, right. This guy's tons of monitors across a bank there. So and he scrolls down, and there's a hotfix. So he goes and installs the hotfix, and voila, problem fixed. A few seconds of just, hey, let me just go take a look at the crash dump and see if there's anything, and was able to get right to the bottom of the problem. Our last section now. How many people experienced a blue screen crash in the last, say, you're raising your hands already. In the last 2 weeks, in the last 2 days, in the last day, since this morning, this afternoon, now. It's pretty depressing. Well, actually, I've got a collection of blue screens that you might have heard about that I can, blue screens out in the wild, I call them. Just, obviously the person was going too fast. No, that's actually a picture. No, it's not. It's a blue screen. This guy tattooed it on himself. It's the real thing there. This is an elevator at Microsoft. That's an airport at a gate. You think that's public, wait till you see this. Everybody see this one? How many people have seen this one before? Raise your hands. Oh, quite a few of you? Yeah. Who knows where this is from? It's the Beijing opening ceremony. So how many people watch that? Like 1 billion people? Not a great advertisement. This is in Times Square. It's also pretty public. It explains why these guys went out of business. They thought. That's Dave Solomon, my co-author on the Windows Internals book. So he's actually going on a trip with his wife. He's at LaGuardia Airport checking in, and he's at the front of the check-in line. He's close enough to look at the blue screen, figure out what the problem is, and he's turned to the people in line behind him and explaining it to them. And then finally, if the day they put it on an airplane, I'm done. That's actually a fake. I'll forget that. All right, let's get on to blue screen crashes. So what happens when blue screen? Why do blue screens happen? One reason: protect data. Stop. What's happened is one of the most trusted components of the operating system, something in kernel mode or a hardware component, has caused a problem that's actually been detected. The operating system is like, uh-oh, something that should never happen is happening here. Who knows what the heck's going on, what the state of the system is? It's totally undefined state. It could be a driver that's got a bad pointer that's spraying all over the kernel and user mode address space, corrupting data, PowerPoint, SQL databases, whatever. And who knows how much damage has been done, but one thing we can do now that we've detected this problem is stop any more from happening. And that's, boom, stop right now, all systems stop, all CPUs shut down, print the blue screen to death, write the crash dump file. So you know that when you reboot the system after a crash, OCA says, hey, can you send this in? And sometimes you'll get back an answer that says, hey, we know what happened here. This particular driver, there's a newer version of it. Go to a Windows update or go to this driver's vendor's website and you can get a new version that fixes the problem. What is going on behind the scenes is that online crash analysis, some human at Microsoft has analyzed those dumps. And what we do is generate crash dump signatures. And we can then, based on the signature of the stack and the drivers that are loaded in the system, and that way we can kind of measure the volume of particular types of crashes coming in, prioritizing the ones that are affecting the most people, going in and analyzing them to figure out what's going on, finding a problem, putting in an OCA database that will direct users to a solution, a workaround, a hotfix, or whatever. But there's lots of crashes that happen where no humans ever looked at it. So at that point, you're not going to get any useful information from OCA. Spend a few minutes to see if you can figure out what's going on. The basic of crash dump analysis, you need to find the crash dump file. Now, the crash dump file's location is going to depend on when your server or workstation, new version of Windows, old version of Windows, but there's a general rule of thumb that will always lead you to the best crash dump file available. First, look in Windows System 32. Sorry, in Windows. If there's a memory.dump in there, that's the file for you. If there's no memory.dump, look in the mini-dump directory and find the most recent dump file in there, and that's the file for you. On Windows Vista and Windows 7, in Server 2008 or 2, you will always find a memory.dump because the system's configured by default that way, but on older Windows clients, it just generated mini-dumps. So this particular case, an admin that had taken one of the Case of the Unexplained classes at a tech ed here, went back, and a few days later, noticed that machines seemed to be sporadically rebooting. Now, this is kind of interesting aspect of crashes, is that unless you happen to be sitting right in front of the machine, you don't know that it crashed, because it's configured automatically to reboot is the default crash policy. If If you've got servers that appear to be rebooting randomly, most likely is they're crashing. So he goes and looks at the event log and sees, sure enough, this system is crashing. He finds a bunch of these crash events corresponding to the reboots. So he goes to find the crash dump file. Let's take a look at that. And crash dump analysis almost always, analyze -v for crash dump, kernel mode crash dumps always does a pretty good job of heuristically finding the probable cause if there's one that's apparent to the crash. So this analyzing our dump, getting our symbols, taking forever as usual. No, please, really, everybody turn off your wireless. No. Actually, that's taking a long time and we're running short, so why don't I go ahead and show you what happens here is that what we would see in that bang analyze come out is this stack trace for the guilty thread. And the debugger would point at this and say, this driver is probably responsible. What's going on here and how do these heuristics work? Here's a behind-the-scenes look at the crash analysis heuristics. It looks at the top of the stack and says, what module is this in? Is it a Microsoft module? Yep. Okay, so we can skip that one. Is it that one? Yeah. Microsoft, Microsoft, Microsoft. Ooh, third party. I don't necessarily agree with it. It's kind of like racial profiling, but it is pretty effective in this case. So he goes and looks at the version on it using this. Let's go see if it's finished, actually. Yep. He goes and looks at the version, which you can do just by clicking on that, and sees that it's over 2 years old. It's 2.5 years old, this driver. So it's likely that the vendor has a new version. Sure enough, he goes to the vendor's website. He right-clicks, and this happens to be a HP ProLiant driver, network driver. He goes to the HP site, sees there's a new version, downloads it. Problems are gone. Server stops rebooting. Just a few minutes, and he figured it out. So that brings me to the end of the session. Again, really, one of the things I do is I actually like to be my family and friends' troubleshooter because it's just really interesting to see if I can go figure out what the problem is. A lot of people try to skirt that. I don't wear one of those T-shirts that says, no, I won't fix your computer. Yes, please, let me fix your computer is what I wear because I want to get practice. The more you do this, the better you're going to get at it. Again, other resources, go back to the other case of Unexplained. One of the best, if not the best book on Windows Internals, Windows Internals 5th edition. Actually, it's the only book. But you definitely need to get that to see the way the operating system works. If you've solved one of these, please capture screenshots and log files and a description of the steps you followed and the kind of intuitive jumps you've taken and send it to me so that I can add it to maybe the Sysinternals book. And PNG is the preferred format because we need high-quality screenshots for the book. That brings me to the end. I want to show you just one last thing. And that is a little trick which is causing the system to crash, not with the blue screen, but with a different kind of color screen. So I've got this trick from a friend of mine that works with Dave Solomon who started doing this in his crash analysis talks. And I'm like, who cares if you make the blue screen happen in a different color? But it turns out people love seeing blue screen happen in a different color. So do you want to see the blue screen happen in a different color? Yeah. So if you don't, you're free to go. But let me just do this. It'll only take a second. Again, I'm going to close course. So I'm going to do local kernel debugging and just refresh my memory on the name of that function that I'm after. Well, is that sprinklers are coming on or something? All right, this symbols are resolving. Oh, this network problem is really annoying. Oh, here we go. All right, so let's go find this assembly. We're going to find the place where the blue screen is actually painted in KI display blue screen. And the place where it sets the color is right here. This 4 represents blue. It's calling NVB solid color fill to paint the blue screen. So what we need to do is change that 4 to something else. And I'm not sure. 4 is blue. 3 is either red or green, and 1 is either red or green. So which one should I pick? 3 or 1? Or wait, 1 or 2? It's 1 or 2. I think 2. You want to see 2? All right, so let's set that to 2. So what we're going to do is go to the View Memory, find that address. Is that the right place? Just let me double check because I want to make sure this works. Yep. And so let's say 2. There we go, 2. So I've just changed the value. And now, just let me shut stuff down because I'm going to be crashing the machine. Save all my work in progress. And the tool that I'm going to use to crash the machine is called, no, it's not Outlook. I feel like we need to give Outlook a little break here. It's a little bit too much Outlook. It's not my fault. This is a tool from Sysinternals. Some people want to know, hey, how can I generate a crash manually on my systems? There's a few ways to do it. If your system's up and responding, you can run not my fault. There's even a switch you can run with not my fault that will, so you can just have a script or whatever, do it remotely through PSExec to crash the machine. Doing it to your friends' computers is always fun. Or you could just run the blue screen to death screensaver on their computer. But here we go, debug, and let's see what color we're going to get. There we go. Oh, it's going to. All right, I'm going to have to show it to you really quickly before it reboots.